Hey guys, so this week we are going to be discussing water. There's a lot of different properties of water that we're going to discuss, and two of those properties that I'd like to talk about today are cohesion and adhesion. So we are going to discuss why water sticks to things, adhesion, and why water sticks to itself, cohesion. To better understand this, we're going to do a mini lab here involving a penny, some water, and an eyedropper. So I'm going to ask you right now to make a prediction. How many single drops of water you think that we can fit onto this surface of the penny before it spills and goes all over the place? So why don't you do that now? Great, you have your prediction. So now we're going to put that in the format of a hypothesis. If then statements, period. So remember, we need to form our hypothesis in the form of an if then statement. Right. So if you made a prediction that you think you can fit more than 10, your hypothesis might be something like, if I put more drops than 10 on the surface of the penny, then it will spill all over the surface. So take a second, put your prediction into the form of a hypothesis. Good job, guys. All right. So now let's do our experiment, see how many drops we can fit onto the surface of this penny. Water we know sticks to things. Water sticks to itself. Water sticking to things is called adhesion. But remember your word parts that we learned: ad and co. The root word is hesion, which means to stick to. So if you take those word parts that you learned, ad, which means to or towards, so sticking to something, adhesion, or co, together or with, sticking to itself, cohesion. All right, here we go. So I am using room temperature water, and that's because I'm trying to eliminate as many variables as possible. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24. Okay, so we saw we got to 24. That used up all the water in my eyedropper, which was you can't see, 1 milliliter. So remember when we did our conversions, we used metric. 1 milliliter of water was able to fit on the penny. Now I'm going to see if I can change the adhesion or the cohesion. All right, so I've cleaned up the water. Next thing I would like to do, I want to change one variable in our experiment here. And so I'm going to see if I can change the properties of adhesion by applying soap to the surface of the penny. So I have a little bit of soap here in a dish, and I'm using a Q-tip to apply it to the surface of the penny. It's the same penny that we used. And now I have the soap on there. We'll see how many drops we can put onto this penny. So what we want to determine is whether soap has an effect on the properties of water. We use it to clean stuff, and so it'd be good to find out how that affects water. So I'm going to use 1 milliliter, which was approximately 24 drops. And we're going to just count to see how many we get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13, so not nearly as many as we had last time. So I wonder how soap affects the cohesion and, remember, the molecules sticking together, and adhesion, them sticking to other surfaces. So hopefully by the end of today's class, we'll be able to answer those questions.